Here's where we left off. We've drawn this horizontal box, horizontal rectangle, and it gets revolved around the axis of rotation. When you draw the horizontal rectangle, just like vertical rectangles, it has to reach from one side of the shape of the area you're dealing with to the other. So from the left to the right, so from the red to the green. And when you rotate it around, it makes the shape of a disc. And like every volume problem, the volume is a sum of little volumes, which is a sum of area times dx or dy, and in this case it's dy. So that reduces every volume problem to a problem of figuring out the area. And the area is the face of a disk, or in other words, face of a circle, so it's pi r squared. So the volume is integral of pi r squared dy. Every volume problem is an integral of a times dx or dy. Okay, so we're looking at pi r squared. So the problem is we've got two letters, r and y. So now we need r as a function of y. And you look at your picture up here, r, like every r, whether it's a cylindrical shell or a washer or a disc, and with washers there are two r's. There's the little r and the big R, but every r is from the axis of rotation right? The axis of rotation to the outer edge, to wherever, right? The axis of rotation to here. So for this is the R, okay? That's the R for this particular disk as it gets rotated around and makes a circle like there. And you can see as you go through all the different y's, start at the bottom with y equals 0 and go up to y equals 4. You start at the bottom, you're going to have a really wide disk with a big R. And as you go through the different values of y, 0, 1, 2, 3, 4, the disk will get smaller and smaller, smaller r's until you get the last one up at the very top. So that's the R. Okay, that's the R. Oops, not very good. There we go, R. That's the R. Okay, so now it's just a matter of writing that R as a function of y. The problem is you got two letters here, R and Y. So now you need that R as a function of y. Okay, so the R is from here to here. And it's similar to the previous one when you were dealing with the R. Okay, if you call that value there x, okay, it's from here to here, so that's 6 minus x, just like before, 6 minus x. Okay, that's the R. So R equals 6 minus x. The problem is that's a y, so an x isn't going to be good enough. So we notice that that x value is right on the red line there, and the red is in the red box here. That's where x equals y. So we write r equals 6 minus x, but x equals y, so r equals 6 minus y. And with that, you'll now have an integral you can do, because all the letters will be y. So the volume equals summing up all the little disks, and every disk is an a dy, is a little volume of a dy, and the a is pi r squared, okay? But the r is 6 minus y, so 6 minus y squared dy. Okay, area times little width, and it's a disk, so the area is a pi r squared, and the r is 6 minus x, but the x is on that red, and that's where x and y are the same, x equals y. Okay, now we need to figure out where to start and where to stop. You're used to doing almost all your integration this way, so you really have to think differently. You almost kind of have to turn it this way, okay? Because you're doing an integral in dy, that little width is dy. And so you're going from where you start to where you stop along the y-axis and in the positive y direction. So you would start here where the area starts, and you would end here where the area ends, looking at it from a y-axis point of view. So it'll start at y equals 0 and end at y equals 4. Okay, so we'll turn it back this way. Start at y equals 0 and end at y equals 4. Okay, so that gives us two different ways to do this integral. The first one we did together live with upright rectangles. Okay, so that had to be an x because they have a little width dx at the bottom. And the problem with that was it had two different ceilings, the red one and then it switches to the blue one, so you wind up having to make two integrals. If you put the box on its side, now the integral has to be in y because this little width is dy. Rotating this around The green axis makes a disk, so we have to use the formula for the disk. And that's pi r squared. The r has to get replaced as a function of y. We walk through that. So you put in pi r squared dy, where to start and where to stop in y, not x. That's what makes these trickier in y, because you do 99% of your problems going this way in x. And every once in a while you have to do one that's in y, and so you have to think differently.